Hey everyone, welcome to my channel, Space Bat. Today I want to just jump right into the topic of this video, brown dwarfs. I first heard of brown dwarfs about a year ago, and they really sparked my interest because I was aware of dwarf planets, such as our Pluto, but I was not aware of dwarf stars. These are called substellar objects, as they do not contain enough mass to sustain nuclear fusion, nor do they have an iron core, which makes a celestial object a planet. They can also be called failed stars, but I don't want to hurt their ego, because it is still a very interesting object to study. Brown dwarfs in the beginning were very difficult to locate in the sky, as they are low in luminosity and temperature. After learning more about them, however, they are becoming slightly easier to locate with telescopes equipped with sensitive infrared detectors. Before their discovery, they were theorized back in the 1960s by Shiv S. Kumar, who initially called them black dwarfs. However, this name was changed to brown dwarfs, as it was thought that these objects contained dust. He hypothesized that there were substellar bodies free-floating in space, incapable of nuclear fusion with hydrogen. We know this is not the first time something was theorized or believed before its discovery, as the same thing happened with black holes. Black holes were proposed by John Michell in 1784, which he called dark stars, then later predicted through the theory of general relativity by Albert Einstein. It was not until its first discovery in 1971, Cygnus X-1, that black holes finally were confirmed. For brown dwarfs, its first discovery was not until 1994, when Spanish astrophysicists discovered the first brown dwarf star named Teide 1, which was found in the Pleiades Open Cluster. Rafael Rebolo, who was the head of his team with Maria Rosa Zapatero Osorio and Eduardo L. Martin, published their findings in an article in 1995 with Nature magazine with Brown Dwarf Discovered on the front page. Since the first discovery of this brown dwarf, it's led to the discovery of over 1,800 brown dwarfs being identified, with the closest one to us only 6.5 light years away. Brown dwarfs are classified due to the atmospheric temperatures. The four classes are M, L, T, and Y. I feel if they would have thrown in the letter E, we could have called them melty stars. They are determined by what class they are in, by mass and temperature, with type M dwarfs being the highest in temps, and with class Y dwarfs being the coldest at 320 degrees Celsius. The coldest brown dwarf was discovered in 2011, with the WISE mission that had been scanning the skies for near-Earth objects, or aliens. Kidding. It was only 77 degrees Fahrenheit. It must have been a very cool star. So what is happening on these dwarf stars? Like we see on our own gas planets in our solar system, there are swirls of gases circulating the star. One of the elements is iron, which can rain down in its liquid form because the star is much cooler than its larger mass cousins. Also, as they become cooler, they can gather up large amounts of methane in its atmosphere that is easy to observe. Because of their low temperatures, instead of nuclear fusion of hydrogen, they fuse together the rare and much heavier element of hydrogen, deuterium. Since they were initially hard to discover in space, the lithium test was created by Rafael Rebolo along with Eduardo Martin and Antonio Maguzu to help locate these brown dwarfs. Due to brown dwarfs' low temperatures, they retain much of their lithium in their atmospheres, which is normally depleted in higher temperature stars. The test, however, is not perfect because it was discovered that in early stages of a brown dwarf's life, it can be hot enough to deplete the lithium from its atmosphere. Brown dwarfs are only about 70 times more massive than our own largest planet in our solar system, Jupiter. They are not actually brown as was first thought. They can be orange or red when in the early stages of life, and as they cool down they become magenta or black to the human eye. As we know around most stars in our universe, after its formation there are leftover dust and gases that can combine together to form extrasolar planets that then orbit around the star. Due to brown dwarf's low mass, that is caused by the lack of dust and gases in the area during its formation, one would assume it was not possible for a planet to form around a brown dwarf star. That did not deter astronomers from searching, and in 2008 they finally found one. It lies 3,000 light-years away in the Sagittarius constellation, orbiting the brown dwarf star known as MOA-2007-BLG-192L. MOA-192b was found with the help of gravitational microlensing and appears to be a gas planet much like Neptune. Not sustainable for life, but I do often wonder what life might be like in other star systems. These celestial objects may have failed the star exam and have been demoted to dwarfs, such as our own dwarf planet in our system, Pluto. But their importance is not diminished as each discovery and understanding of these objects in our backyard lead us closer to unlocking the answers to our questions about the universe. Thanks for watching.